And we're back. In this next segment, we're going to talk about concurrent updates. And so what we kind of mean by that is when we have more than one person updating a database concurrently at the same time, right? So with Microsoft Access, you are allowed to open up the same file and have multiple users working on the same database file. And the way that concurrent updates works is that it locks the file at the record level. And so kind of what we mean by that is that you can open up the same file with multiple users, that is allowed. But if one user is working or updating or modifying a specific record, another user will not be able to edit that same record. So that's what we mean when we say that it kind of locks it at the record level, as opposed to the file level, where if someone had the file open, right, another user would not even be able to open that same file. An example of that is like an Excel document or a Word document that's shared, and one user has it open and is working on it, and then a second user tries to open that. They're probably only going to get a read-only copy of that file, meaning that they can't edit the file. That's kind of locking it at the file level. Again, Access locks it at the record level, and that is denoted within Access by a little pencil icon. So if we take a look right here, we can see that there's a little pencil icon in here next to this record, and that indicates that record is locked because it's being edited by a different user. So that's what it looks like within Access. So with Access, it's not too much of an issue having multiple users work on it, because it's meant for a relatively small database and a relatively small organization. When you're talking about enterprise level database management within a very large organization, now you're talking about many people working on a single database, potentially across wide areas geographically, right? And so when you do that, when you start to incorporate things like trying to access databases concurrently across the internet and things like that, it brings in a lot more complexities to that, especially in regards to security. So sometimes organizations might implement private networks so that you can access internal database applications, VPNs and things like that. It just kind of makes the whole management aspect of it a little easier to manage. And so when we're dealing with multiple users accessing the same database and modifying records and changing things, there's a couple kind of key issues that arise when doing this. And those kind of the two main ones are what we refer to as data concurrency and data consistency. Concurrency meaning that, again, we're just having multiple users access the same data at the same time. And the other issue is data consistency, meaning that if we have someone modifying records and changing data, well, what is the other user that's also logged into that database? What are they going to see? And so these are typically the most common issues that arise when dealing with concurrent updates and things of that nature. And so when a user is working on a database and they're modifying whatever it is that they're working on, each thing that they do, each task that they do, they refer to it as a transaction. And so when this occurs, it kind of triggers a number of different steps that the database management system has to complete in order for the data to remain consistent for each user, right? Coming back to that data consistency issue, We want to make sure that everybody that's working on the database is seeing the same information consistently. Otherwise, someone might make changes, overwriting other changes, or whatever the case may be. And so one example of that is Oracle, and kind of the way that they handle the issue of data consistency. Again, making sure that people are consistently seeing the same data if you have multiple users logged in concurrently. Oracle processes these transactions that users are doing in a series of different steps that kind of help maintain the data consistency by preventing the following types of database concurrency problems. And so those three problems that the Oracle tries to prevent are dirty reads, non-repeatable reads, also known as fuzzy reads, or phantom reads. So what a dirty read is a transaction that reads data that has been written by another transaction by a different user, but it just hasn't been committed yet. A non-repeatable or a fuzzy read is a transaction that rereads data that it has previously read and finds that another committed transaction has modified or deleted that same data. So that's a fuzzy read. And then we have a phantom read, where a transaction reruns a query, returning a set of rows that satisfy a search condition and finds that another committed transaction has inserted additional rows that satisfy the condition. So these are three types of concurrency problems that Oracle, right, and again, we're just using Oracle as an example here, they take a series of steps whenever a transaction is committed. They take a series of steps to prevent these type of concurrency problems from happening. And so by doing that, they're ensuring that consistency, that data consistency across all users. And so another concept that may be implemented that helps kind of govern the definition of a successful transaction is through the acronym ACID. Atomicity, consistency, isolation, and durability. And so this is a concept of ensuring a transaction is successful even if there's some type of problem or interruption or something like that in the process, to kind of help kind of ensure that the transaction is still successful if something like that were to occur. The kind of an example that they use in the text is like ordering tickets, like concert tickets, right? If we didn't ensure data consistency, if we didn't do that, then we might run into issues with people buying tickets for the same seat at a concert. So that's kind of what makes, data consistency such an important thing. And so a couple other common techniques to help with concurrency control are timestamping, which is a technique basically used to determine the order of processing records based on essentially timestamps that are applied to records. And the other one is two-phase locking, which just blocks other transactions from occurring that's trying to access essentially the same data while another transaction is completing. Good. Yeah. So there's that same screenshot, having that record locked in access. Good. So that's supporting concurrent updates. Again, these are really potentially serious issues if they're not addressed when you're dealing with multiple users and multiple people concurrently accessing a database, trying to change and edit records, right? Particularly if they're trying to edit and modify the same record. We certainly need to have concurrency and consistency mitigation techniques in place to kind of help with that. So good. So I hope this was helpful for you guys, and we'll see you in the next segment.